let's move along. We'll just continue this thought process now. So from the diagram, we see that since sine x equals opposite over hypotenuse, then the cosine of pi by 2 minus x is opposite over hypotenuse. The opposite meaning the same side that we labeled as opposite before, which is the adjacent for this cosine. So if these two things are both opposite over hypotenuse, then that means that the sine of x equals pi by 2 minus x. And similarly, we could show that cos of x is sine of pi by 2 minus x. So that just shows that an acute angle theta in any right angle triangle has a complementary angle. Oh, you're so good looking. Of pi by 2 minus theta. And if we take a look at that triangle that we just looked at from before, so angle theta is pi by 3 and pi by 2 minus theta is the other angle, therefore that other angle is pi by 6. Okay, and that gives us the pi by 6, pi by 3, pi by 2 special triangle that we've used in the past. Okay, so then if we want to write relationships between the trig ratios of pi by 3 and pi by 6, we see that sine of pi by 3 equals the cosine of pi by 6, which you already saw from the table that you filled out before. Now, if we were to rewrite this angle of the equivalent ratio as a difference involving pi by 2, we would get sine of pi by 3 equals the cosine of pi by 2 minus pi by 3. And that, of course, is pi by 6. Now looking at we're going to draw conclusions of relationships between trig ratios of theta and the trig ratio of the complementary angle, pi by 2 minus theta. Those angles are called, or the trig ratios between them, sorry, are cofunction identities. That's what these are called. So sine of theta equals the cosine of pi by 2 minus theta. So sine and cosine and complementary angles are equivalent. Therefore, if we take a look at this table, sine theta is the same as pi by 2 minus theta. Cosine theta is also pi by 2 minus theta. And as it turns out, instead of another primary trig ratio, tan theta is equal to the cotangent of pi by 2 minus theta, as you saw in that original table on the other page. And cosecant theta is secant of pi by 2 minus theta. Secant theta is this cosecant of pi by 2 minus theta. And the cotangent theta is the tangent of pi by 2 minus theta. Okay, so we saw all this in that table that we saw on the other page that you filled out before. This just gives a bit more of a formal definition to it. And moving along to the last page here. If we look at angles, suppose we have some angle theta. We know that this is y for this triangle, this is x, and this is r. So the sine of pi minus theta, well, that would be over here, pi minus theta, and basically that's beta. That's what we're looking at. This is beta right here. That is actually also, again, opposite over hypotenuse, y over r. Which means that sine of pi minus theta, y over r, equals y over r sine of theta. Okay, so because of sine of pi minus theta equals y over r and sine of theta equals y over r, then obviously sine of pi minus theta equals a sine of theta. Now cosine of theta is adjacent over hypotenuse, which is x over r. And cosine of pi minus theta, again this beta angle over here, pi minus theta, so that's the whole angle here. The theta itself is the beta. That is, over here we've got negative x, there's y, and there's r. Then this would be negative x over r. So we see that cos of theta is x over r. This cosine is negative x over r. So whatever this is negative of this. Okay, because the only difference between the two is this one's negative and that one is not. So cos of pi minus theta is the same as negative cos theta. Okay, so if cos theta is x over r, negative cos theta is of course negative x over r. So cos of pi minus theta is equal to negative cos theta. If we look at this at tan theta here, tan theta is opposite over adjacent. Tan of pi minus theta, again that's theta is supposed to be the beta that we're always used to. So this angle here, of course from the positive x-axis right at the terminal arm, opposite over adjacent is y over negative x. The only difference between this trig ratio and this trig ratio is the negative. So tan of pi minus theta is the same as tan of theta, but the negative of that. So that would be negative tan theta. Okay, I'll do one more here and then I'll ask you to complete the rest of this table. Again, for this, we've got y here, x here, there's r. This is negative x, negative y, and radius again. So the sine of theta is y over r, opposite over hypotenuse. Sine of pi plus theta, here this beta angle, the angle itself goes from the positive x-axis all the way around to the terminal arm. So that sine is opposite over hypotenuse, which is negative y over r. So the sine of pi plus theta is the same as negative, and because sine theta is y over r, sine of pi plus theta is negative of sine theta, as you see here. Okay, so can I ask you to please continue working on this? Fill out the rest of these trigonometric relationships here, and then we can check those in class when we see you again. So after you finish that, please work on the first 2 or 3 questions here, and you can work on the rest of that in class when we get together again. So thank you for your attention, and we'll see you in class.